Hey everyone, let's finish 37 and then do 38. Remember here we're talking about composition of functions. We're going to do all of these problems if we can. Remember that we're given charts for f and for g, and we just need to compose a function for each, right? So let's look at C. F of 6. I think it's always best to write it as f parentheses f of 6 to just remind yourselves that you're plugging in f of 6 into f. Well, we know that f of 6 is, just from looking at the chart, I guess it's 7, right? So we have f of 7 right here, and then we know f of 7 is 6. So f of 6. That's kind of interesting, right? G of 6. G of f of 6, f of f is 6. Interesting. All right, next up, for D. Let's try a little bit nicer than that. D, we've got g of 6, which again is g of 6. Now, g of 6 we have is 8. G of 8 is, by definition, 5, right? There we go. Do that. Okay. Last but not least, f of g of 9. Let's see what we've got here. Well, that's going to be f of g of 9, of course, as always, right? G of 9 is 4. Now, something kind of interesting happens right here. There is no f of 4. Notice that, right? There's no f of 4. So I'm just going to say that this does not exist, right? So note that they say, if possible, find these things, right? It's not possible to find f of 4. Okay? So sometimes that just happens. Okay? Let's look at 38. The reason, by the way, in case you're wondering why that fails, is sometimes the range of the inner function can be bigger or more inclusive than the domain of the encompassing function. That's what you have to watch out for. Right? So for 38, again, another analogous situation, right? Our functions are t and s. Okay? By the way, note that the independent variable here is little t. Don't worry about that, right? We're plugging s in for t, right? Or we're plugging in big T in for x. So don't worry about the independent variables. Composition still works out regardless. T of s of 1, well, that equals, remember, same sort of thing, t of s of 1. Well, s of 1 is 0, so we have t of 0, and t of 0 is 2. That's how you do that, right? Let's keep going. We did t of s. Why not do s of t? So again, right, we're finding t of 1 first, and then s of whatever that is, right? T of 1 is 3. So I guess we're finding s of 3, and s of 3 is 2. Interesting. T of s is 1, and s of t is 1. Or sorry, t of s of 1 is 2, and s of t of 1 is 2. It doesn't necessarily work out that way. T of 1. Remember, this is t of 1. What's that going to give us? Well, t of 1 is 3. So I guess we've got 0. Right? Again, t of 1 is 3, t3 is 0. So you're just like, it's like a connected dots almost. 1 to 3, 3 to 0, right? That sort of thing. Remember, we're always going inner to outer. Inner to outer. Okay? You can think of it as PEMDAS, right? You know, do the stuff inside the parentheses first. D. Well, we did t of t. Why not do s of s? S of 1 is 0. S of 0 is 1. So I guess it's like we didn't do anything really, right? And last but not least, t of s of 4 T of S of 4. What's that going to give us? Well, S of 4 is 5. Do we have a T of 5? We do not. So again, we have a non-existent solution. Okay. So there you have it. Some function composition, right? Should be quick and painless, but conceptually it can be a little bit, a lot to take in. So be careful with this stuff, Thanks for watching.